It's time. Change the scene. Her thoughts, they're getting too intense and driving her into a downward spiral. We must pull them out. In a world where your thoughts are not your own, they're shared with everyone. It's hard to have a moment to yourself. Your privacy feels compromised and you struggle to have independence. But what if you had no control of your body? You couldn't control your fingers, hands, arms, or your entire skeleton. You couldn't perform the daily activities life brings. It would be nice to have someone tell your brain to cook some food while also retaining some independence. This dystopian society is what the brain-computer interface strives to achieve. It's Agent RX, and welcome to Episode 8 of The Next Prescription. Today, we are going to dive our way into the mystical realm of the brain-computer interface. We will learn exactly what it is and the science behind it. Then, we will understand how this technology came to be. We will look at its current applications and then conclude ourselves by peeking into the challenges it brings into society. The brain-computer interface, or BCI, is a device that is connected to the neurotransmitters of your brain. We'll go into what a neurotransmitter is in our next section. But the BCI intercepts these signals and then outputs them onto a computer. The signals can then be transferred into another type of machine to execute an action, or they can be studied. BCIs can also allow for researchers to input their own signals into the brain so the body can execute them. This is helpful for people with disabilities and diseases such as epilepsy to regain some independence in their lifestyle. Now, how do these devices connect to our brains? Whenever we perform an action, whether it is running a marathon or closing our eyes, our brain must instruct the necessary parts of our body in order to perform such actions. This is done by sending signals throughout our bodies using neurotransmitters. The BCI intercepts these signals, which is achieved by either implanting a device into the tissue of one's brain or wearing a wearable device on the outside skull. Implants are used for more serious conditions, such as a person with paralysis or epilepsy. They can attach to the regions of the brain that control certain limbs. They are more accurate in reading the signals since they measure directly from the brain and can avoid interference from other tissues. However, since implants must be surgically added into the brain, they contain the risk of surgery-like infection. On the other end, there are caps which can be used as BCIs. These devices are placed on the individual's head and monitor the signals using conductors on it. Wearable BCIs are more common for controlling a mouse cursor or a robotic arm. Now that you have gained some consciousness of what the brain-computer interface is, let's learn how we got to such a marvelous technology. There is a long 200-year discovery. Now that you have gained some consciousness of what the brain-computer interface is, let's learn how we got to such a marvelous technology. There is a long 200-year chain of discoveries that led to the ideas and the concept of a BCI. But it gets a little too detailed and complex. So let's start from when we started creating machines with the intent of a BCI, which started in the late 1960s and the early 1970s. Researchers wanted to record the brain activity of humans. However, the technology was new and scary. Having computers interact with your brain? No, I think I'll pass. Researchers had to resort to other animals to study. Their main culprit were monkeys. Although initial recordings were tough to accurately record, they were able to make the first leading discoveries to the idea of creating a link between the human brain and some external machine. In the 1990s, scientists and researchers were starting to develop how BCIs would work and their implications. One major point of discussion were ERPs, or event-related potentials. There are brain signals that occur in response to the environment or stimuli. The most prominent experiment during this time was the P300, which was performed by Dr. Farrell and Dr. Donchen. This experiment allowed for users to select letters on a computer screen by just using their brain. It was a major breakthrough in the world of BCIs because it allowed us to study how the brain processes information and how a computer can connect to our brain. In 2008, we started to see the use of BCIs in real life. John Dongue at Brown University created the BrainGate project. It consisted of inserting a tiny device into the brain that would keep track of neural activities. The activity was transferred into computer signals, which allowed for users to control external devices such as a computer cursor or robotic arm. It is crazy to think how far we have come in such a short amount of time, but there is still more to this technology and more we have to discover and improve. The future of this technology is exciting, but before we jump into it, let's pause and smell the flowers of this technology in the present. BCIs are used across the board, starting with helping those with neurological disorders such as paralysis. Paralysis is a condition where a certain muscle group in the body cannot function due to brain signals not being able to reach it. If the patient were to use an implant BCI, it could act as the brain in delivering the signals for the specific region of the body that the patient can't control, leading patients the ability to utilize parts of their body they never thought to be possible. BCIs can also aid in motor recovery from serious injuries that inhibited parts of a body from working, like a brutal car accident where one's leg was destroyed or a stroke. The BCI can track the progress and see where exactly the brain is struggling to release of the necessary signals in order for the part to function. This would most likely be achieved with a wearable BCI, but an implant could be used too. The implant would restore the function rather than help the patient heal. It is like using an elevator versus a staircase. The staircase you had to climb yourself. This is representative of the wearable BCI. The elevator, however, it got you to the same place and even faster, but you didn't really do anything. That is representative of the implant BCI. BCIs are also used to diagnose medical conditions by studying the individual's brain waves and chemistry. This would most likely be achieved by a wearable BCI since there is no need to alter the function of the brain waves. There are even more applications of BCIs, but the ones I've listed and briefly explained are the most prominent in the medical world. One honorable mention of BCIs not in the medical world are their ability to let humans play with electrical devices without actually moving their bodies. What I mean by that is that BCIs can allow us to play video games without a controller, or type an entire essay without lifting a single finger. It uses the signals from our brains to intercept what we are trying to do and then execute them onto the machine directly. It's similar to the P300 experiment. I'm sure as you've listened to this episode so far, you've noticed that something feels a bit off about this device. And you'd be right. I mean, doesn't it seem a bit too invasive of our bodies? Let's dive into the folds of the ethical and privacy components of this technology. BCIs are a machine, a device that has been coded into. Just like with any device with code, it is prone to cyber attacks. Imagine if someone with an implant for the paralysis that gives them no control of their hands and arms got attacked. The cyber attacker could have the person start punching themselves or injuring themselves until they bleed. These devices must be closely monitored once put in use, but even then it takes a split second for something terrible to happen. Another major concern with BCIs are its costs and what that means. A BCI is worth hundreds of thousands of US dollars. This hefty price tag is not one most people in the world can afford, which will lead to worsening a fight for universal health care. This life-changing device is something that once again can only be received by the rich, leading those of lower incomes to suffer when they could actually benefit more or the same from the same device. It is not a choice to be born or develop these neurological disorders. So why is there a restriction to who can receive care for them? The development of the brain-computer interface is an exciting time for us all. Let us return to the image of a computer guiding our thoughts, both a promising life for the future, yet also a warning of the dangers of this technology. BCIs hold the power to restore movement, communication, and dignity to those who need it most. Yet, they also force us to question what control and independence truly mean. BCIs are something I am carefully watching grow in our society, and I can't wait to see them become more widespread. Their threats on autonomy and safety may make others very cautious, but the idea of what they could and are achieving makes me more hopeful than doubtful. They don't change our bodies from the root like many other technologies explored, such as CRISPR or 3D bioprinting, which takes out a whole level of concerns. But that doesn't mean we don't struggle with any. I'd love to hear your thoughts on this remarkable technology entering our world in the comments. Thank you for tuning into the next prescription, and until next time, this is Agent RX signing off.